In this video, we will solve a numerical on viscosity. Now, in this, the annular space between two coaxial vertical cylinders of equal length is filled with an incompressible liquid of constant viscosity. So, viscosity is given as constant. The outer cylinder is held fixed and the inner cylinder is slowly rotated about its axis at a uniform rotational speed, assuming that Newton's law of viscosity holds good. Now we need to pick the correct option, in which what they are saying that in options the tangential velocity of liquid varies linearly across the gap. Viscous shear stress in the liquid is uniform across the gap. So somewhere they are asking about velocity, how it will vary with the depth, or viscous shear stress tau, how it will vary across the depth, whether it is constant or variable. That is what we need to calculate. So fine, let us start with this. So in this diagram, this is the outer cylinder. This is outer cylinder which is already fixed. This outer cylinder is fixed, while this is inner cylinder. This is inner cylinder. Now, Newton's law of viscosity holds good. So that means tau value is equals to mu du over dy. This is valid in this case. Now, mu value is given because constant viscosity liquid is filled in between. So remember that in between here, this is completely filled. Here, this is completely filled by a liquid of constant viscosity, right? So this is completely filled with the liquid of constant viscosity. Now we'll pay attention how we can calculate how this plate can be seen, an example of this equation, how this equation can be applied to this particular problem. Now radius we are measuring from the center. From here to here radius is r1. From here to here radius is r2. Now this value du over dy can be seen as the change in velocity. Now look at this. The velocity at this surface will be how much? At inner surface, velocity will be r1 into omega. Outer surface velocity will be 0. So that means the velocity gradient do exist from here to here. At this point velocity will be 0, and at this point velocity will not be 0, velocity will be somewhat maximum. So velocity will increase from this point to this point because this is rotating. This inner cylinder is rotating. Then only this fluid will rotate. So now y is taken as radial distance. So we know that this du over dr in this case. Why? Because y value we are representing from radius. Du over dr, that is velocity gradient with respect to radius. How velocity is going to change with radius will be equals to tau by mu. From here this mu will go here, so this is tau by mu is equals to this, and this must be constant. This must be constant. Why this must be constant? Because the fluid is moving with, again it is mentioned here that the fluid is moving with uniform rotational speed. So remember this, the velocity is actually, angular velocity is constant. Now If it is the case, then how to approach further? We can write it as du value can be given as tau by mu into dr, and if we integrate it within the limits like this, tau by mu into dr, if we integrate this, then we will get the value as this will be u, that is equals to tau by mu into r, but because we have not applied any limits, so we can write it as plus some constant. See, in this question, the limits can be kept because radius we know that it is varying from r1 to r2, and we know that du value is also from 0 to something. But in problem, we were not supposed to find out the numerical values. So we are not going for calculation. We were just supposed to find out the options. We just need to calculate how the variation is, whether linear equation we are getting, whether quadratic equation, whether cubic equation, what kind of equation we are getting. So what we are getting here is, by looking at this expression, u is equals to tau by mu into r, and this is some constant. So this is r, which is variable, and this is constant, and this is the value of u. So here we can say that the velocity varies linearly. So you can see the tangential velocity of the liquid varies linearly across the gap. So this option seems to be correct. The tangential velocity of the liquid varies linearly across the gap. This seems to be correct. Now check it. This is the tangential velocity of liquid, which varies because r to the highest power is 1. So this is linear variation. Tangential velocity u varies linearly with r. Anyway, we have written that option A is correct, right? Thank you.